right, this is Saxon, lesson 33 on page 151. Don't forget to subscribe, smash the like button, and turn on notifications. All right, major rules of algebra. Somebody remind me of the major rules of algebra when I have an expression. What are the rules?
Eliminate denominator.
It would never be eliminate denominator for an expression. Yes.
What was an expression again?
What is an expression? Somebody give me the example of an expression. 3x squared plus 2.
Okay.
So you want to add like terms?
So we can combine like terms. All right, what else? What? No equal sign, okay. No equal sign. But what else can we do? How do we simplify? What are some ways we can simplify?
Taking the number out of the column.
So we can factor or we can distribute, right? We can factor or we can distribute. All right, what else?
Multiply by 1.
And when we multiply any term by 1, what would be the goal for that? Why would we multiply any term by 1? The goal would be
Cancel the denominator.
not cancel. Common denominator. The goal would be to have a common denominator. All right, that would be the goal, to have a common denominator so that we could then move the sign to the numerator and add our numerators. All right, now, what about when we have an equation? What are the rules for an equation? What is an equation? How is it different from an expression?
It has an equal sign.
It has an equal sign. It has an equal sign. So what are the rules of algebra if we have an equal sign?
This is where you want to eliminate.
This is where we want to eliminate the denominators. All right, what can I do on both sides of the equal sign?
Multiply and subtract.
Okay, let's just talk about addition and subtraction. What do
That's what I meant.
Yeah, what do I do with addition and subtraction? It's just any number I can add or subtract from both sides of the equal sign. So I can add or subtract any value from both sides of the equal sign. All right? Or on both sides of the equal sign. All right, what else can I do? What do I have to do with multiplication and division? Yep.
You can divide both sides by a certain number.
So when I multiply and divide, how is it different from addition and subtraction?
Each term.
To every term in the entire equation on both sides of the equal sign. So I can multiply and divide by any term, but it must be applied to every term in the equation. I should say multiply and divide by any value to every term in the equation. It has to be applied to every term in the equation. All right, so when your original problem is an expression, these are the only things you're going to do. mathematically, you're going to multiply by what is equivalent, the equivalent of 1 to go to a common denominator. With an equation, we're going to move things around on both sides of the equal sign. And we're going to divide every term. We're going to multiply every term by values so that we can solve the equations. Does that make sense? All right. Now, this, I can simplify expressions, which we kind of said, factoring and distributing. But what terms can I simplify in either one of these? When is the only time I can simplify a term? Yes. Simplify terms that are multiplied. Only. I can only simplify terms that are multiplied. All right? So if I have 4x over x plus y, is that an expression? Is that an expression? Can I simplify the x's? Everybody look right here. Can I simplify the x's? Why?
Because the bottom term is a single term.
That's right, because this is added. Now can I simplify? I can only simplify because the terms are all multiplied. So my x's can eliminate. I end with 4 over y. For the same reason, if I have now I have an equal sign, and I want to eliminate the denominator. What do I multiply each term by? 6. I multiply each term by 6.
Least common multiple.
The least common multiple. And now can I simplify? Yes, because these terms are multiplied. So when I simplify, that becomes 3x plus 2y equals 36. All right. Got it? The rules are fundamental. That's the first part of this lesson. All right, I'm going to spray the board and white. The second part of this lesson is a complex fraction. Now, we've talked about complex fractions. Somebody remind me what a complex fraction is. What's a complex fraction?
It's like a fraction over another fraction.
A fraction over a fraction. That is correct. Or even a fraction over one number, or a number over a fraction. But you have a fraction either in the numerator or the denominator. And that makes it complex. So when I have a fraction over a fraction, is that an expression or is that an equation?
Expression.
It's an expression. So how am I going to simplify that? How am I going to make that just a fraction and it no longer be complex? I'm going to multiply by 1. And then I'm going to have a numerator over denominator. All right, so look at example 33.1. 33.1 is x over y plus 4 over xy over a over y. That is a complex fraction. Before I multiply by what is effectively 1, I want one fraction over another. not a fraction plus a fraction over a fraction. I want a fraction over a fraction. So the first step would be to get a common denominator in the numerator. So what would be my common denominator in the numerator? XY. So to get to XY, I take this first term and multiply by x over x. So that I have x squared over xy plus 4 over xy over a over y. Now once I have a common denominator, we do not add the denominators when you have a common denominator. You only add the numerators. So the sign moves to the numerator and xy is my one common denominator. I'm going to write the entire numerator over. So we have x squared plus 4 over the one common denominator over a over y. Now that's a fraction over a fraction. That's where you want to get, is a fraction over a fraction. Once you have a fraction over a fraction, I've still only got an expression. That's my middle fraction line. So to make it a simple fraction, I multiply by the reciprocal of the denominator over itself. Okay, y'all think these are simple concepts. But I'm going to tell you, when you get to your higher level maths, you're going to struggle with these rules. Do you want to know how I know? I've personally raised 3 engineers. And I've had my youngest, all 3 of them, come to me and say, how do you work this problem? And do you think their mom understands it? No. But do I know the rules of algebra? And yes, I have been able to help them solve it because I can follow the rules. And what do they forget? The rules. And I don't know how many pre-calculus classes I've taught, but every year, you know what people forget. Smart people. People that excel in Algebra 2. They forget the rules. I am going to hound the rules because the rules help you get through any problem. All right? So don't take this lightly. Take this seriously. It's an expression. I'm going to take the denominator. It's reciprocal because this times its reciprocal equals 1. And then I'm going to multiply by the reciprocal over itself because that's the rule. So I'm going to multiply by y over a over y over a. The denominator becomes 1. Now I'm going to have a numerator over denominator. But I have terms multiplied. Now, could I simplify anything from a to here? No, because it's added. Even if I had a like term, I cannot simplify. But can I simplify numerator to denominator? Yes. I can eliminate the y because everything in that denominator is multiplied. And then you leave a 1. All right, so 1 times anything is the other thing. So in my numerator, I'm left with x squared plus 4 over a times x. And that is simplified. All right, so this is so important. I've seen one of these problems on the ACT. And I will tell you, people sit for the ACT and they're like, I don't know how to do that. I'm like, common denominator, because there's no equal sign. Or I'm like, eliminate the denominator. What did Miss Haley teach you, right? No equal sign, common denominator. Equal sign, eliminate the denominator. All right? All right. Let's look at the next example. All right, example 2. It's slightly more complex. All right. I have terms added in the numerator over a single denominator. I want a single fraction in the numerator. So I'm going to make a common denominator. What is going to be my common denominator in the numerator?
Y times x
Y times x plus
plus y.
y. That's what it's going to be. Y times x plus y. Those terms multiplied. So what do I multiply this term by to get to that common denominator? Y over y. So here I end up with a y. What do I multiply this one by?
X plus Y.
Yes, x plus y over x plus y. Distributing the m, I have mx plus my, and it's all over my common denominator. Now I can combine my numerators and write them over the one common denominator. So the sign, when it's positive, it's easy. When it's negative, it has to be distributed to every term in the second term. So I end up with ay plus mx plus my over y times x plus y over x over a plus m. Now I take the denominator, I multiply it by the reciprocal over itself. A plus m over x over a plus m over x. The denominator becomes 1, so I just have the numerator. You do not have to multiply these out. You can write this ay plus mx plus my times a plus m, and we'll just multiply x out at the beginning. xy times x plus y. Your book multiplies everything out, I do believe. No, it doesn't. That's good. I wouldn't. I would not multiply all those out. There's nothing that we can eliminate because if I had an a plus m in the denominator, then I could eliminate that binomial, but I don't. So this would be your final answer.